All right. Hi, everybody. I am Aaron Wilson. I'm with the North Central Climate Collaborative. We're here once again to provide this bi-monthly webinar. Today's topic is on agrivoltaics, and we'll get into that just a second. Just as a reminder, NC3 is made up of a group of extension professionals across the region, North Central region, and we're just we've been for a while working to increase the flow of climate information for extension, farmers, natural resource managers, communities, a lot of different connections, obviously, that we in extension across the region work with. So, we're focused on kind of an increase in adoption of climate smart or smart practices across the region and helping to improve water management and things as well. So we certainly appreciate you being here today to listen to this great webinar. You can sign up for the newsletter, also for NC3, and Allie's put the link there in the chat. We will be having a period of for question and answers here. So throughout today's webinar, if you want to put your questions in the Q&A box, we will tee those up at the end of today's session. Today, we are joined by two groups of extension and researchers. One, we're going to start out with folks in Wisconsin, Diane Mayerfeld and Will Fulwider. They're going to talk about some of the work that they've been doing with interviews with farmers, landowners, and other stakeholders about their views and questions on agrivoltaics. Then we'll transition to a group from Ohio State University, including Eric Romick and Brady Campbell. And they're going to discuss their agrivoltaic work, looking at testing types of forage and cover crop trials on a 180 megawatt capacity solar farm. So this should be exciting today. So I'm going to go ahead and get out of the way and let the stars of the show take over and turn it over to Diane Mayerfeld with Wisconsin. Thank you.
Diane,
Is,
yeah.
is that looking all right? All right. Well, thank you very much for that introduction. And I am just going to quickly kind of give you a little background about agrivoltaics in general and where we are in Wisconsin looking at it. And how can I get my slides to advance? There we go. So what is agrivoltaics? I'm assuming most of you know what it is, but just very quickly, it's the integration of farming with solar electricity generation on the same land. And there's lots of different things you can do. There's a photo here of annual field crops, one of vegetable production, one of growing forages, pollinator plantings, which is the most common, and solar grazing, which is the most common agrivoltaics, I would say. There's some debate about whether pollinator plantings fully count as agrivoltaics. So why are we interested in agrivoltaics? Well, certainly I can say here in Wisconsin, what we are hearing from communities is that while they like the idea of energy independence and they like the idea of renewable energy, they are concerned about the fact that the prime places for putting solar energy generation are the same as prime farmland. So you see here two maps of Wisconsin, and the dark green on the map on the left shows the prime farmland, and the yellow and orange and show the best places to put solar generation. And then next is the dark red. So you can see there's actually a lot of overlap there. So just diving in a little deeper, the three probably first things that people would get excited about: can we grow annual crops? Can we grow vegetables? Can we grow perennial forages on the same sites as these photovoltaic generation facilities? And yes, but there are challenges there, and it's not something that utilities or solar developers are open to primarily for cost reasons right now. So if you raise the panels up high enough, that you can run equipment underneath, it adds a significant amount of cost. And it also creates more soil disturbance because you're having to hammer those posts much further into the ground. So what I've heard is that for every foot above ground, it takes 2 feet below ground. So that's a major challenge. You can also just space panels further apart, but then the question is really how much farmland conflict with solar generation have you really avoided? Because to produce the same amount of megawatts by spacing those panels further apart, you are having a larger footprint per megawatt. As I said, basically, why not raise the panels? There, what you see here is sorry, it's one of these things. The disconnect between what you earn from the solar generation and what you earn from the agriculture. So it just, the financials of being able to grow a little more crop just don't pencil out against the costs and financials of the energy generation. So that basically, from a utility perspective for now, leaves us with 2 types of agrivoltaics that are primary interest to people. And I say for now because this field is definitely developing, and there may be new ways of building these panels that would allow them to be put up higher that just aren't industry standards right now in the future. So the pollinator plantings, or sometimes they're called ecovoltaics, they're great. They bring biodiversity benefits. They bring soil health benefits. That it is somewhat expensive to establish, procuring the seed and also the very intensive management it takes for the first probably 4 years, maybe more than that. Another big plus is there's minimal conflict with access and maintaining for operating the energy generation site. But it's not production agriculture. Pollinator plantings may support agriculture, and in some cases it may allow something like beekeeping, but it's just in terms of the number of acres we're talking about, just in Wisconsin, probably upwards of 300,000 acres of farmland. There's not an agricultural need for that many acres of pollinator plantings. So right now, the area of greatest interest and greatest activity is solar grazing. It also has some biodiversity benefits because the perennial vegetation that is established can be diverse. Again, because it's perennial vegetation and covers the soil year round, it has soil health benefits. Typically, the types of forages one would plant for sheep grazing have lower seed costs and lower establishment costs. Helps the utility by managing the vegetation. That is a cost the utility would have anyway. Again, that kind of pasture has minimal conflict with the utility's need to occasionally access the site. And it is very much seen as an agricultural use. And there are a number of benefits, including it providing shade for the animals. So that's kind of the setting we had. And then Will and I are cooperating on a small internal grant that we received from Extension. And then I'm also doing this work as part of a Department of Energy grant. And kind of our first step in this internal grant was to talk to farmers in Wisconsin. And so what did they say? So the next couple of slides, I'm just going to pick out some of the key things that they said. And then I will turn it over to Will to explain the next part of our little project on agrivoltaics. So the first thing is most of the farmers we talked to liked the idea in principle. So here's a quote saying that this multiple use of the landscape, it is a win-win. where we can do both some type of agricultural practice as well as the solar harvest. And another quote from another farmer pointing out that the solar operator in any case is going to have to hire someone to manage the vegetation. So they might as well hire animals to do that. Another thing we heard repeatedly is that people saw potential for this to solve the problem of land access for beginning farmers. And you can see the quote from someone saying how, this could be a way for beginning farmers to access land without having to purchase or rent their own land if they knew that they could count on being able to graze or rent enough of their own land. If they knew that they could count on places to graze their flock. Interestingly, we also heard from another farmer who is in a situation of inheriting farmland, so not a beginning farmer with zero access to farmland, but explaining that the economic reality, even in that situation, is that working with renewable energy projects is really critical for them to be able to transition to the next generation. Another thing that was brought up was the question of liability. What are the risks when you combine agriculture and solar production on the same site? What are the risks to human health and safety? What are the risks to the livestock? And what are the risks to the equipment? And who has to carry what insurance? So that's an area that farmers definitely want to know about. Another thing that came up over and over again from farmers, people who didn't happen to be sheep farmers, was questioning what the market potential is for sheep. And here's a nice quote from one who said, "So I was talking to the power company and I said, okay, when was the last time you had beef? And they said, oh, last night. I said, when was the last time you ate lamb? And they're like, oh, maybe 3 months ago." And so what we did hear from a lot of the people we talked to is that they think there's potential and they'd be way more excited if you could do agrivoltaics with cattle. On the market thing, I will note that this is a short-term problem, potentially not a long-term problem. In 2024, 73% of lamb consumed in the US was imported. So there's room for a lot of potential growth in the US lamb market. But there are barriers of cost and barriers of processing right now. And so for a farmer to look at getting into this, someone who's not already a sheep farmer, it does raise questions. From, we heard, this is another comment we heard over and over again, which is that the solar developers just don't get what the needs of the farmers are. And we heard this both from people who are interested in agrivoltaics but haven't been able to do it yet, and from people who are already doing it. So the quote below is from someone who's been actively doing agrivoltaics, and what they said is, even though they're doing it, it's hard to know who did what management last, vegetation management. And they also said they work with a number of different sites. And what they pointed out is there's a huge range in how the sites are managed. So a lot of this is a question of bringing developers up to speed. So a couple of other things that came up, which is that the shade for animals can be valuable, and that it's good public relations for the solar companies. And then again, the benefits include access to land, it's an income source, and it can benefit both the developer and the farmer financially. And to sum up the challenges, getting to an agreement, even figuring out from the farmer's perspective whom to work with is a challenge. Figuring out the liability and the insurance is a challenge. They had questions about what the best forage would be and how to manage it. Working with the utility to set up some basic things like water and internal fencing. There were comments about, even with good communication with the utility, there are just some major impacts of construction. And really, so many of these come down to communication. And I think with that, I'm going to turn it over to Will.
All right. Can you all, Diane, can you hear me coming through?
Yep, you're coming through great.
All right, excellent. So I'm going to talk a little bit about kind of the more agronomic side of that internal grant that Diane had mentioned, that is actual agrivoltaics demonstration project or research project that we have going not too far from the UW-Madison campus. It's about 15 miles southeast of Madison. And there's a lot of different research projects going in on this one, solar development in hydrology, soils, greenhouse gas emissions, and agrivoltaics. And there's actually two different projects going on looking at agrivoltaics. One of a kind of perennial berry project looking at blackcurrants, and then our project looking kind of more at forages, which will hopefully dovetail nicely with what Ohio State is talking about there in a second. So Diane, next slide. And so on this site, what makes it kind of interesting is that we have different racking arrangements and spacings all on the same site on relatively similar soils. So this is, again, that 50 mile southeast site from Madison, and there's two different arrays of fixed tilt, one of which is 17 feet spaced and one of which has a 21-foot spacing, to see if that more sunlight that comes through the ground between the panels helps to boost kind of the agricultural production here. And then there's also a fixed tilt that are spaced that are actually quite high up at about 8 feet. We're not doing research under those panels just because it's a smaller array where a lot of sunlight's coming in from the sides. And then a single axis tracker system as well. That's kind of that most top part of the picture that you see there. You see them oriented a different way. And we have our forage mixes planted in all three different arrangements, not that fourth, that fixed tilt, but we are the purple research plots in that map to the right side of the slide that you see there. So we have them in the fixed and the single axis trackers to the far north top part of the map there, in the middle and that larger spacing, and then also at the bottom and that closer spacing, as well as in full sunlight treatments to evaluate the differences that we have and those serving as a control. And the whole idea is to see if we change the racking system, if we try and accommodate agriculture a little bit more in our solar arrays, can we boost production? How can we maximize agricultural production, especially focusing on forages and sheep grazing on these sites? So next slide, Diane. And what we've chosen to look at is kind of some of our keystone forage species in Wisconsin pastures. Orchard grass being a primary one of those. If we can head back, there we go, thanks. So that is our bunch grass. We have two bunch grasses that we're looking at in two different mixes, a meadow fescue and an orchard grass, those replacing the other ones. And then we have a legume species, red clover, in both of those two different mixes, as well as a sod-forming grass or Kentucky bluegrass to kind of fill in that space, compete against weeds between our bunch grasses. So those are two different forage mixes that we have planted, along with a monoculture of alfalfa. We are in the dairy state. Part of the goal here is to see, can we, in the future, if we have good communication with the utilities and buy-in, can we think about haymaking on these sites as they are? We have some very, very large sites in Wisconsin. I did some math. There's not enough sheep in all of Wisconsin to graze some of these sites. So how can we try and mechanize this to get agricultural production under solar arrays in the state? And these will all be compared to the kind of standard pollinator mix that we have spread throughout the site. And these are all replicated 3 times under each of the arrays, and then in the sunlight treatment as well. Next slide, Diane. And so what we're looking at is we're going to be taking forage clippings from each of these plots, figuring out how much biomass production they have, and then sending it into the lab for forage quality analysis. And what we've seen so far, we planted this past spring after several delays in the construction process, is that as we suspected, there's more growth in the sunlight treatments than underneath the panels, and that we're seeing that the grasses are really doing quite well in the sunlight treatments and not doing as well in between the panels and what we're calling the shaded treatments. There, the red clover and legumes are really thriving, especially the red clover. And in those shaded treatments, the red clover leaves are larger, which is interesting. They're a little bit more kind of leggy, as well as they're searching for more light, but those larger leaves that's where a lot of the forage quality from these legumes is being derived. So larger leaves equals higher forage quality. So that's an interesting aspect that we're looking at. We planted in the spring, but we actually haven't taken a cutting yet because of weed pressure on the site and also mowing schedules. And that's getting back to what Diane was saying about the communication aspect. Is there's subcontractors of subcontractors working on these different sites, and even one that there is all this research going on, achieving that communication that allows us to get into the site when we need to and make sure that the plots aren't being mowed, for example, is a process of learning. And so we'll do our first sampling here coming up in early September, when we have the management established and everything like that. So stay tuned for more of the kind of forage production and quality coming from our end, but I believe that's what Ohio State's going to be talking about as well. So that might be just a perfect dovetail into their conversation. Next slide, Diane. Here's some resources from that Diane put together on solar grazing. And then finally, our contact information. Well, we have questions or comments, which we'll get to at the end, and our contact information is on this slide here. Thanks, Diane, for moving those slides ahead.
All right, thank you, Will. Thank you, Diane, for your presentation. We're going to transition now over to Ohio State University with Brady and Eric. So we'll let those folks come on and share their slides. Just a reminder, we've got a couple of questions in the Q&A, so be sure to put your questions in the Q&A box, and we'll get those at the end. All right, take it away, Brady. Thank you.
You bet. Good afternoon, folks. Appreciate the opportunity, and thank you, Aaron and Allie, for having us on here. My name is Brady Campbell. I'm an assistant professor in the Department of Animal Sciences, where I serve as the state small ruminant extension specialist. And with me today is Eric Romick. Eric?
Yes. Hey, good afternoon. Can everyone hear me okay?
Yes,
Perfect. And the slides are showing for everyone?
they are.
Great. So, as Brady mentioned, my name's Eric Romick. I'm with Ohio State University Extension. I work 100% extension appointment as a statewide field specialist on energy education. So, I get pulled into everything from oil and gas in the eastern part of the state to utility scale solar in the western half. So, thanks for having us today. I don't know, Brady, before we jump off, or before we jump into the slides, I really appreciate the intro and seeing what's happening at up in Wisconsin. I think one of the things I wanted to share before we get started is kind of the driving forces in some of our decision making as we started to discuss utility scale agrivoltaics. And this goes back probably 6 or 7 years as we've been tracking down a number of different opportunities to do some test plots with forages. And two things that really drove our decision making was, number one, we wanted some solutions that we felt were scalable to the type of development that we were seeing in Ohio, which is, for the most part, projects that are 100 megawatt or larger. Seems to be the trend right now. And then the other piece is, we were looking for solutions that we felt were economical, that had the potential to drive the implementation through economics versus regulation. And so as you think about kind of our approach and some of the research that we're doing here, scalability and economics are two of the things that we were really trying to focus on as we were looking for solutions and putting together this research project. So with that, Brady, I'll kind of move through the slides here and hand it off to you.
Yeah, you bet. Thanks, Eric. And a big shout out to our teammate, Elizabeth Hawkins. She's one of our other co-PIs on this DOE grant that helped us put this presentation together. But as Diane and others said in Wisconsin, their work was associated with DOE. Ours is as well with our farms program, that foundational agrivoltaic research for megawatt scale. And so you can see that our project name there, Agrivoltaics, the integration of agricultural, forage, and livestock production systems within these utility scale solar farms. And so we've got a site over in Madison County in the state of Ohio that we're working on graciously. And we've got th four different focal areas, or these are what we call our priority research areas. You'll hear us call buckets as well. So you can see we've got forage crops, we've got complementary grazing strategies, precision agriculture, and soil health. But today we've only got enough time to be discussing two, and those two should be popping up here. It'll be our forage crops. So thinking about maximizing production value through assessing that forage crop through different seeding rates, forage quality, and forage yield that we'll get into here in just a bit. And then also thinking about soil health. So trying to quantify the impact of construction on that environment itself.
And one of the things to add, Brady, we did have some preliminary research, a case study site where we didn't necessarily have a large enough solar site to have any type of replication that we could do statistical analysis on. But and waiting for this project as we had this partnership evolve to do this research, we were waiting for them to go through the power siting board process. Then you're going to have your 18-month construction window, and we really didn't want to wait that long to get some of these results. So we did have some case study sites where we got some preliminary results in terms of seeding rates and yield estimates and some quality data as well. So that really kind of set the stage for our partnership for this project to scale up. And I think one of the great variables, and I think a big challenge as we think about agrivoltaic research, is getting that site access. And having that partnership where you can get site access to do research. And as Diane mentioned earlier, one of the challenges is liability, right? There's major concerns because these are operating power plants, and so to just show up and do research is a challenge. But the way that these utility scale sites are constructed are very different from your smaller behind the meter type projects. So we felt that it was really important to try and kind of put this project together so that we can get some research data, on a site that actually was impacted with the construction practices that we're seeing in these larger projects around the state. So, Brady, I'll hand it back to you.
I think we're good. We'll keep rolling on, Eric. We've
Yeah,
got a lot of pictures.
Yeah, this slide kind of speaks for itself, right? So this is I think 1,100 acre site in total, and then this is kind of our research zone up here in the top left. I think we have around 70 acres of forage and grazing plots, and then some additional acreage that we're using for equipment trials and control and so forth. So, all right.
Yeah, so we thought that pictures speak more than words, and so we wanted to put up some of these photos that we've been able to capture as we've been doing some of these field operations. So we'll just kind of follow along, working left to right, top to bottom. You can see in that top left-hand corner, our crew is out there utilizing just a standard seed drill where we only sprayed herbicide on the ground. You can see that those forages or those weed pressure was killed post-construction to allow us to seed some of those forages that Will and others were discussing earlier. You can see that we are using UTVs and other small pieces of equipment and implements to be able to spray and manage some of the weed pressure that's within these sites. Obviously, we can't be spraying for broadleaves and some of our cool season hay mixes that do contain clovers, but the alfalfa variety that we did use for this project itself was Roundup Ready, so we were able to successfully do it with that. Far top right is just another image of that drill that we were able to utilize.
And we had
Go
to
ahead.
calibrate the different seeding rates there. I think is what we're trying to communicate with that picture, Brady, because when we get to our experimental design, you'll see that we have different seeding rates for each of our forages.
Sure. Good point, Eric. Obviously, being within that site, we are required to maintain vegetation height. So that was some of the pictures that you saw on the bottom there. Just trying to demonstrate all the pieces of equipment that we've had access to. So during the haymaking process, of course, getting that mowed, after mowing, tedding it out, then raking, and then baling. You can see that we've got a round baler to be able to utilize in this site. For the data collection that you're going to see, or the data that's represented coming up, we actually used a small square baler. It was an inline baler. It just worked better for the purposes of data collection and measurements. You can also see that it is dependent upon time of day when we can use certain implements and when we can access some of these areas. But our intentions were a lot of this equipment to be able to operate regardless of the angle or the rotation of these panels. And then the far right just simply represents some of the equipment that we're utilizing, a lot of GPS equipment, focusing on one of our other focal areas as it relates to autonomy within these solar sites. So just wanted to provide a couple pictures here as it relates to some of the forages that we're growing. We are into year 2 of our growth. You can see the small squares represented there in the top end. Eric mentioned the different seeding rates that we had. Eric, do you mind talking just briefly about those real quick before we get down into the nitty-gritty?
Yeah, so we had for both our cool season hay test plots and our alfalfa, we did 100% the recommended seed rate for Ohio, and then we also did we had test plots with 75% of the recommended rate and 125% of the recommended rate, and we had 4 replications for each of those seed rates, and then
Yep.
in the control zones we did 100% recommended rate.
Yeah, you bet. I will note that the year 1 photo there in
Oops.
2024, a lot of us probably are aware of the drought that occurred much across the nation, and you can see it also represented here with our cool season hay. Just very, very little growth. It was just a tough time to get things established. These photos were actually captured. The year 1 photos were actually captured late September, early October when we kind of got that welcomed rain. And in reality, folks, it worked out really well for us, and we're quite pleased with the pictures that you see on both of those slides off to the right-hand side with year 2, how lush that forage has come in within these rows. Continuing on with some of those field operations, we're utilizing a disc mower there, an offset one. You can see that it helps us allow us to get up underneath those pilings just ever so slightly better. You can also see that there are some challenges, and those are the realities as it relates to some of that weed pressure that are near the pilings as well. But again, just kind of walking us through the whole process of mowing, tedding that hay out to help it get dried, raking it into a windrow, and then ultimately going down through the center of those alleys and getting it baled up for that product that we're chasing. Year 2 is when we were able to harvest hay. Our first harvest occurred there in June. Contrary to belief, these photos are taken on the same day. There was a lot of work. There was a lot of forage, a lot of dry matter, and a lot of bells and whistles to work through. The picture on the far right there with the hay in the shed all tucked in nice and neat. That was 1:30 a.m. the following morning. So we were committed to it to get those forages baled because we were expecting rain the next day. No different than any other type of agricultural operation. Just some finessing that had to be done with the panels and piles that are kind of obstructing our way. So in terms of forage production, we're going to get into some of our results in terms of yields coming up here in just a few. Um, in terms of our experimental design, as Eric mentioned earlier, randomized complete block design, we did have 3 forage species, the alfalfa cool season hay mix that we mentioned earlier. That mix is primarily red clover, orchard grass, a few others mixed into there. We also have plots out there that are analyzing or evaluating warm season annuals. Those that we chose to take a look at was teff grass. Unfortunately, because of the drought last year, we didn't get a great stand. And because of some challenges with funding, we weren't able to replicate that here this year. And then we kind of round out with the seeding rates that Eric had mentioned earlier, with the 75, 100, and 125 of those standard recommended seeding rates. We used several different methods to collect yield data. We were using a rising plate meter for those that are familiar with sheep grazing or any type of livestock and grazing operation. A plate meter, once calibrated, can work really, really well. It gives you a real-time estimate of what's available in terms of pounds of dry matter availability. Because we had such a lush growth pattern on these forages, we were maxing out that plate meter every time. So we've chose not to utilize that moving forward, especially for the hay plots, because we do want that tonnage without sacrificing too much quality. However, we are utilizing your basic square technique where we are clipping those forages to ground level. We'll go dry them off and weigh them to get an estimate of our dry matter availability. And then after the baling process, you can see that we are going going around collecting those bales and getting some weights on those square bales to give us an idea of what the difference is between that standing forage that's available. And of course, we know haymaking isn't 100% effective. There is a bit waste in there, unfortunately. So we were collecting pre and post harvest from that standpoint to better understand what was there, what we were able to collect or gather up in a hay form, and also what that quality looked like as well.
Just a couple notes, Brady. So the rising plate meter was helpful in year one, where we had to do, we didn't necessarily harvest in our establishment year. We had a lot of strategic mowings to manage the weed pressure, and so that was a way that allowed us to kind of get some type of an estimate in year one. The other thing, just to kind of note, so we're going to be sharing some data on our yield data. We're still processing the quality data. So, the clipped samples were ultimately dried and processed in our lab where we're working on getting the forage quality results, but then also took core samples from the bales to get some of that data as well. So that won't be part of today's conversation, but it will be something that we have moving forward.
Absolutely. Thanks for that, Eric. I'm going to move my little tab around here so I can see a bit better on my end. Year one for our forage biomass, our yields that we're collecting. You can see that there were some differences here based upon the superscripts. We can see that the control 100% seeding rate is representing the same as what we saw there at the 100% seeding rate within the solar array itself. So that is good news that shows that at the same seeding rate for our establishment year for alfalfa, there was no ill effect or negative effect associated with shade. And you can see that those that were on the opposite ends of that seeding spectrum were just slightly less. And all of our forage yield measurements are going to be in tons per acre because that's how we're collecting it. And that's ultimately how it's going to be sold for hay at the end of the day for us in Ohio. Moving on to our cool season hay, you can see quite a bit less. It just took a little bit longer for those forages to get established. But however, here it tells a bit of a different story that when we take a look at our red bar, which again is our control 100% seeding rate, just did a little bit poorer in terms of establishment and overall yield when we compare it to all of our seedings that were within that solar array.
And again, these first two slides were from our year one establishment year, and I guess just from an observational standpoint, when we were running through collecting the plate meter data and some of our Canopeo images, it seemed like, especially in the cool season hay plots, we had a lot more clover that was present in the eastern side of those alleyways, which was capturing that morning shade. And unfortunately, we don't have data to support this because we didn't have our weather station set yet. But when you think about we kind of had those drought conditions. I think that morning shade was really helping some of the clover, and that's kind of showing up here in the bar chart.
Absolutely.
Year two.
Going into year two tells a little bit of a different story compared to year one as it relates to our alfalfa here. You can see that the alfalfa that was in our control area, almost half the yield when we compare it to some of those forages that were within that solar array. However, we should note, based upon the statistics that are provided, that they all have the same superscript, so therefore there were no statistical differences in terms of dry matter yield based upon where they were in the solar site.
And if this continues, as if we continue to see that, I mean, that 75% seed rate, there could be the potential to get similar results with less investments in seed.
Absolutely, especially with the cost of alfalfa, that make a lot of producers happy.
Yep. So moving on, year two hay.
It is not popping up for me. There it is. Same story, folks, as we take a look at cool season hay, as we compare it back to our alfalfa there in year two, those forages, especially at the 100% and 125% seeding rates within the solar array, far superior in terms of their dry matter yield when we compare it to our control area. So again, still tells a story that we're getting some yield, and I know preliminary wise, we are seeing a slight uptick in quality based upon digestibility and crude protein percentages for those forages that are within that array compared to our control samples.
One of the other things that doesn't show up in the charts, Brady, but we were kind of talking about the other day as we were on site doing our third cutting was, we a lot of talk about the pollinators, but we really noticed a lot of bees and butterflies that were in that hay in those hay plots, I guess, on site.
Yeah, you bet.
All right, so we're going to move kind of transition away from discussion on some of our yield and look at a little bit of data that we have related to soil compaction. So I guess I'll just give a real quick background on some site kind of history before we jump into some of the slides. But what we included in our DOE study was we really wanted to kind of get a little bit of a better sense of what is the impact to the topsoil. Participating in a lot of solar workshops around Ohio and presenting in some, but listening to a lot. I hear everything from, well, once the solar runs its course, you just take it out and go back to farming. And then I also, on the opposite end of the spectrum here, once you touch that site, we'll never be able to farm it again. But there's no data that really kind of supports that either way. And so we were anxious to try sense of what is the impact. And so what we were able to do was we were able to gather some pre-construction compaction data. So using a cone petrometer, we were able to get access to the site before the solar construction equipment ever showed up. This site was the site that we had access to was a 500-acre field. 250 acres were tiled. They were in a corn soybean rotation. They did no-till corn. There was no history of cover crops on the site, but they did note that there were no grain carts or grain wagons moving and operating within the field. They used 20-foot wide equipment and extra wide tires for all their tillage equipment. And so just kind of a little bit of a background. And we were able to get just over 500 samples as we think about kind of where we started with some of this pre-construction compaction sampling. So why are we concerned about compaction? I guess we kind of touched on that briefly in the intro, but here's a couple of images to kind of help you visualize what the concern is. So obviously there's going to be impact to your access roads and laydown yards where they're removing some topsoil, but also just the day-to-day movement of equipment throughout that site. We're interested to see what is the impact from a compaction standpoint. When you think about the design, again, have a couple of different things that we're looking at. So we did a randomized complete block design looking at 7 different cover crop species so that we're able to kind of track how do these cover crops help remediate that topsoil compaction. And then again, we were using a cone petrometer, and that gave us a compaction reading in terms of your pounds per square inch on 1-inch increments. So every inch we would get another reading. And anyone that's ever run one of those, it's very sensitive, and it really works out specific target back.
Sure does. And fields have to be at field capacity, meaning at maximum moisture levels for those things to read accurately as well.
Yeah, thank you for that, Brady. And so we really had to kind of work to make sure that we found ideal conditions to do this. So kind of looking at the preliminary results here, you can see we really have 3 different lines that we're focused on. So the red line here is our pre-construction. So this would be 2023 before anything happened. 2024 is the post-construction. So you can kind of see visually there where a lot of our agronomists and soil scientists refer to this as the compaction nose at this kind of 6 to 10 inch depth, where there's evidence of compaction, which is most likely connected to the construction activities that were taking place on site. As we look at the gray line here, this is representing our year 1 readings after the establishment year. So after a year of having forages on the site, we did see a reduction in those 2024 post-construction levels. So, with that said, and want to stay in my lane. I'm not necessarily a soil scientist, but from what I'm hearing from those in our team that are focused in that area, anything over 200 is something that you're concerned with in terms of that compaction starting to impact root establishment and growth. So it is good to see that we're starting to remediate that. And the other thing that we think this data will be useful for, so not just how well will our forages work post-construction from an agrivoltaics perspective, but also thinking about how we can apply some of this data from a decommissioning standpoint, where similar impacts are going to take place on that site when they remove it as what happened when they were building it. And so hopefully we can learn something from this in terms of how to get these sites back to being the most productive that they can. So looking at the 2024 to 2025 results, we're comparing our 7 cover crops that we had established. And so this is, again, comparing 2024 in red to 2025. You can see there was a reduction in every treatment that from year to year. But just like to kind of note in the text here that these readings are at the 4-inch level. I'm not sure if I would have liked to include one at the 6 or 8-inch level, but I'm dealing with some issues on my computer. But nonetheless, that's kind of the level that these readings are taking at. So you'll note that all of these, even in 2024, were below that 200 mark, where we noticed in that 6 to 10-inch depth, we started to see a little bit more evidence of that compaction taking place. And so, but nonetheless, it is good to see that we're starting to see some evidence of those cover crops helping to remediate that action.
You bet. And so I'm being cognizant of time. This is kind of us wrapping it up. Just some closing thoughts and some observations. At the end of the day, folks, it is feasible at commercial scale. However, there are some challenges, and we'll talk just a few about those. But you can see some of the images here as it relates to us collecting our forages in that dry matter form. One of the big ones that we've experienced time in, time out is proper drainage. And so ensuring that those developers that go in there know where those tile lines are. Eric mentioned that earlier. Part of the site was tiled. They have had to dig up some of the tile and retile the field because they've destroyed that and putting those pilings into the ground there. And so as a result of some of this intermittent flooding, we've had some challenges in some parts of these fields with the forages taking. In parts of our treatments within these rows, you can note a difference in color. A lot of weeds or undesirable forages, our foxtail, our sedge, some of those species are starting to emerge in those areas, which ultimately decreases the value of our forages that we're trying to create in those specific rows.
And honestly, this isn't something that's unique to our site. I've been on utility scale solar sites all across the state, and this is a very common image. There's pockets and pools where there's damage to that tile, and the site's just not draining properly. And so, we do have some examples of developers that are actually. There's one site that I'm aware of in Ohio that they're tiling the site, they're retiling the entire site as they're building it. And so I think that we're starting to see some evidence of lessons learned being applied because of the interest in trying to farm these sites. Here's our next issue, Brady, row spacing.
Absolutely, absolutely. And so Eric and I've had countless conversations with the developers and O&M operators and vegetation managers and everybody else in between. And so every site has a different story, it seems. So as we think about row spacing, that's going to dictate the ability of you being able to produce or harvest any type of crop within these facilities.
And I think there's 2 things to really focus on when we think about spacing, Brady. Number one is, there's a minimum amount in order to effectively, produce hay on a site at a commercial scale, right? Across, a 2,000, 3,000 acre site. The other thing that I think we need to start and so that's kind of the step one. I think the next level is to optimize that, right? So think about the equipment that we're using and optimize the space, adjust the spacing to optimize that. And so what do I mean by that? Like we don't want to, like here you can see in the image, like we don't want to do a full cut coming down and then a partial cut coming back. Like, so how do we optimize the total output from that unit of diesel fuel that we're burning? So, and we can do that by adjusting those alley widths. All right, issue
Absolutely.
number 3.
End of row turn radius. And so this has become quite the problem. Thankfully, as the site was being built, we were able to get a change order put in. And something that you aren't going to be seeing within these rows are the cabs cable system hanging down through there, because all the cable in our research zone, for the most part, at least where our hay crops are, all those cables are buried. And that's a good example of those cab cables there as well. So thinking about utilizing this equipment that farmers would typically have or that's already available in the market, are we able to get those implements and equipment turned around at the end of these rows, or do we have to back all the way back out? And then understanding where those cables and combiner boxes are within the facility. What type of equipment can we use? Are we going to have to use zero-turn mowers and UTVs to get in and out of those sites? Do we have to start looking at equipment that's going to be attaching to that front end of the skid steer to get our crops in there and get them managed appropriately? Those are all questions and things that we intend to investigate.
And going back to our opening slide, this is feasible and this can be done. But I really can't stress enough that there's a lot of work that needs to go in on the design side in order for this to work, right? And there has to be a commitment from the developers, to implement these types of practices so that you have a quote unquote hay ready site that we can go through there and commercially manage those forage crops. All right, with that, Brady, I think we're A, out of time, and B, at our last slide.
You bet. Thanks, guys.
Yeah, thank you, Brady. Thank you, Eric. Also want to bring back and thank Diane and Will for their presentation today. And I will have Eric and Brady's contact information as well here in just a moment. Diane shared hers in the chat box as well, so we'll get that to you. We've got several questions. If there are more, we'll try to get to as many of these as possible today. But if there are more, please put your questions in the Q&A box. So we'll kind of jump back or jump around here just a little bit. Early on, there was a question about, you said it's significantly more expensive to raise solar arrays higher. What does that mean in terms of dollars or percent of the cost of a solar project? So Diane or Brady, you want to take that?
Well, I'll take my stab and maybe Brady will have a better answer. That's a great question. We don't know the answer. We in Wisconsin have just submitted a technical assistance request to the National Renewable Energy Labs of that very question. Can they give us a dollars and cents figure? Basically, what I know is anecdotal. When Will and I asked some developers about, would you consider raising it? It was a hard no.
Yeah, we've experienced similar issues, Diane, on our side. I think that, and Eric can correct me, but on the size of our site, even raising the piling 6 inches was going to be upwards of $2 million just to get that accomplished. So thinking about what that cost is and what the return is are things that they're still considering. So at the end of the day, after our project is complete, I saw a question in here, and hopefully this helps address it. We are going to be looking at enterprise budgets to help be able to provide these to farmers, producers, developers, O&M operators, and everybody else in between to show that farming between these rows, whether that be with livestock, a forage crop, a vegetable crop, or anything else in between, can be successful.
All right, thank you. Kind of moving down here. From a former consultant to pipeline construction, one of the kind of concerns that they see pretty dominant here is, what is the financial incentive for solar utilities to allow agrivoltaics? You're scratching your head, Brady.
Community acceptance is what it is, in my opinion, and what we've seen across the state of Ohio. What we are doing here in Ohio with our grant and with our goals is putting farming back into farmers' hands. And so there are generations that are trying to figure out what to do, how to continue to pass this land down on into the system, what's the most viable situation. There is some pushback from that local community as it relates to putting this power station in their backyard. And so when we present the idea of being able to farm within these systems and give farming back to these farming communities, it seems to be a positive benefit from that standpoint.
And I'll add just a little more, basically saying very similar thing to what Brady said. Anecdotally, in Wisconsin, one of the sites it was the way it works is the developer typically approaches landowners, and one of the landowners said, yes, if you let us do agrivoltaics. So that would be where the landowner is requiring it. And then the communities, at least in Wisconsin, our law does not allow communities to simply pass a moratorium, but they might be able to do things like requiring, we're still working that out, like requiring the sites to accommodate agrivoltaics. So lots and lots of questions about how that would work. And then a third anecdotal thing, and Will, you could probably explain this better. One of our success sites, the farmer initially approached a completed agrivoltaics project about raising sheep there, and they initially said, no, I don't think we want to deal with the hassle. And now then they changed their mind. So the incentive is, as I said in the beginning, they're going to have to pay for vegetation management anyway. And when you have a farmer grazing sheep, they're getting some huge free public relations for that vegetation management that's occurring. Will, I don't know if you have anything to add to that.
Yeah, for that one, I think the key is that it's a much smaller local utility. It's not a massive kind of regional utility, and so they're pretty much the bureaucracy train is smaller there. So if there's someone that's passionate about it, they're able to move that through that lineup of bureaucratic obstacles a little bit more easily than a kind of for a larger regional utility. So, I mean, honestly, I think it really takes someone that's interested in it from the utility side, is willing to see that through and talk to the right people and grease those wheels, because for a lot of people it's a black box, you know. And I've gotten a lot of calls after Diane and I did. There's an article about agrivoltaics, and people are like, "How do I get in on this? Who do I talk to?" And it's just like, great question.
Yeah, and that gets back to that comment from the person who's grazing multiple sites, that it's just a huge range between some developers who are excited about it and really willing to work with it, and the ones who are doing the bare minimum.
Yeah. As I mentioned early on, you know, one of our driving forces was the question of economics, right? Is it economical? If it makes dollars and cents, we don't need to regulate it. And but the challenge gets back to, you know, it's a utility scale site, it's an operating power plant, and you're asking, you know, we're asking the developers to make, you know, major changes to how they design this, even though, like, in our opinion, they're minor, right? So not major changes in terms of, you know, adding more steel and building it up, but tweaking the design, making sure that we have, you know, a 25-foot end of row clearance versus 10-foot. And those, you know, burying the DC collector lines, you know, that's an additional cost up front. Now, the question is, how long does it take them to recover that, right? And that's where, you know, one of the outputs of our grant is going to be, you know, an enterprise budget sheet that looks at, here are your input costs to producing forages on a solar site, and here's your potential revenue stream based on, you know, our yield results and our forage quality. Now, you know, I think that'll take a major step towards kind of helping these utilities understand the why. And it still goes back to this idea of, you know, it's a cost they're going to incur anyhow. Diane, you mentioned vegetation management, right? Like, that's one of the major O&M costs that they have. And so if we could kind of help remove that cost, and all of a sudden when we look at our enterprise budget sheet, your land input values are very low, if not nothing. But now all of a sudden the utilities don't have that high O&M cost for vegetation management. I think there's the potential where it could be a win-win, but until we have that data to show them this is why you spend the extra money up front, it's a tough sell. And so that's why we don't see this done at a commercial scale. I mean, to be very honest, there's a lot of agrivoltaics taking place. There's a lot of really cool ideas that work and have been demonstrated, but there's very few of them that are done on the hundreds of thousands of acres going in all across the US, right? And that's where we need to get.
Yeah, very good. We've got several more here. I'd like to take at least one more if we can, maybe two if you guys got quick time. But thinking we can combine a couple of these when it comes to market for sheep themselves, sort of how strong is the market? And then there's a separate question about any work extensions doing to expand those markets or connect that interested in the growth as well.
I'll just be really brief with that one. There is a ton of market availability. As Will alluded to, there's not enough sheep in Wisconsin to do Wisconsin. There aren't enough sheep in the United States to be able to graze what's happening in the state of Ohio. So that's the reality. There's only about 5 million head here in the United States. Not unfortunately, land market's really, really good. The thing that's going to happen is that people are going to continue to build their flock size. So there isn't going to be any marketing or trading of these animals because there's two separate entities, is what I found out. There are those folks that are using sheep to graze, and that is a vegetation management system. That is their enterprise. They're not really focused on producing a high quality product to put onto Americans' plates. And then there are going to be folks that are going to switch that gear and they're going to find ways to be able to market that offspring or those excess animals within that grazing system. But with all that to be said, we've got a lot of growing left to do here in our U.S. sheep flock size. So we're going to be maintaining and retaining a boatload of sheep in order to graze everything that's coming online here in the next several years.
And I would go back to the statistic I shared, that apparently something like 73% of lamb was imported in the US. So that gives you a little bit, we could triple or quadruple our lamb production. But as I said, there are a lot of short-term barriers to getting it processed and to building the infrastructure for that. And right now it's obviously cheaper to import it. Someone asked the market for wool. The market for wool is what I hear from most producers is terrible.
Penny pound.
What's that?
A penny a pound.
It doesn't quite cover the cost of shearing
Mhm.
is often what I hear.
$6 to $10 a head to get them shorn, and they yield about 7 pounds of wool. So do the math there.
Mm. Yeah, it doesn't quite work out. So I'll end on this last question. There's a couple other technical ones. I don't know if others, Brady or Eric or others, want to jump on and answer in the Q&A about row spacing and some other things. But Diane, you mentioned the communication problems or issues and challenges, let's say, between producers and solar developers. And this person asks, what are some of the approaches that we could take to reduce these barriers? It seems there's a good interest in that, thinking about PR firms that may be standing in the way at times, but how do we overcome those challenges? And I think that's a good question to end on today.
I'd love to know. I think some of it is education and telling those success stories of those good relationships. I mean, as I said, in Wisconsin, we have some, as Will said, they're small commercial scale, but they are commercial scale. They're in the 20 to 100 megawatt range. So they're not the pictures of the horticultural stuff and the beautiful community agrivoltaics where it's on 1 acre or 2 acres. We do have some great success stories. And so I think sharing those success stories and coming up, this is what Extension does, coming up with the detailed recommendations, both for the developers and the farmers. And the resources I shared, the American Solar Grazing Association has some great resources, and there's a couple other ones. But I have to confess, I'm still at the beginning of the learning curve of developing these things.
Brady, Eric, any final comments? Will? Okay, well, let's go ahead and we'll close out there. First of all, I want to thank Diane, Will, Brady, and Eric today for joining us on this great webinar and lots of information. And certainly the recording of this will be made available at the North Central Climate Collaborative website. We might throw that back in the chat as well. We'll be with you again in a couple of months here on Monday, October 27th at 1 p.m. Central, 2 p.m. Eastern. We're going to work sort of in a workshop style, but present some climate tools for those that are interested in utilizing some of those climate service tools that we have up there. So again, the link to previous webinar recordings and sign up for that newsletter, that link is in the chat, along with contact information for our folks today. Again, appreciate the opportunity, and we will see you down the road. Thanks so much.
Thanks, folks. Appreciate it.
Thank you.
Thank you.
Thanks.